Hello and welcome to our first update for the engineering car project at De Anza College. I am Chase Yamate. I'm one of the group members. I'm team leader for Team 4. We are doing a independent build, tube chassis, independent drive motor and steering system design that you guys are all helping fund and promote. This is really great. I'm really excited to do this, and this is why we're giving you guys some inside footage of what's going on. I just got my first shipment of all the computer components, and I wanted to share some of the things that the fundraiser has helped provide for our group, and some really cool components. So let's go ahead and check it out. So here we have these are preliminary motors. This is the actual motor portion. They spin quite quickly, but they have a 141 to 1 gear reduction gear motor. This makes it spin much slower and much more powerfully than this little motor can handle. And then what we have here is a 90-degree gear drive transfer case, basically, that transverses the rotation from one direction to another, basically allowing us to run the motors perpendicular to the chassis. Actually, let me go ahead and get the chassis and we can go ahead and show you what we're doing. So currently what our design is here's the body that you've seen on the pictures, and where these motors are going to sit, as you kind of see in the CAD drawings, is they're going to be mounted pretty much like this, and that way, you know, they don't have to be mounted crossways and then you have motors interfering with each other, because there's going to be two of them. So we've got these transverse motors. They'll lay perpendicularly, and hopefully the battery will lay nicely between those to allow all the weight to be right in the center there. Most of the weight's going to be in the motors and the battery. Everything else is pretty lightweight. But these are really cool. They have also quadrature encoders, which are 2-wire encoders, allowing us to sense not only speed of these motors but direction. And the motors we're actually going to be using are they have 463 ticks per revolution, so we can actually sense less than a degree of rotation in the wheel movement, so it's going to be really accurate. But otherwise, they're just motors with encoders, gear motors. We will have the larger motors. The shipping date is apparently November 18th, which is in a few days from now. I'll update with the website and see if they got those in, but hopefully we'll get the bigger motors. These spin at about 100 RPM, and the bigger motors are going to be spinning at about 1000 RPM, and we'll be able to harvest this gearbox off of these for the transverse action. So on to what we have here. We have the Arduino Uno that was provided by the class. This is the one thing that was provided by Professor Lamb. It's pretty cool. We've all kind of taken it home and explored with it and uploaded the program and got some stuff to flash around, and finally we're having some sensors to plug into it, so now it's pretty exciting to see what capabilities we can have. Right here we have a line trace sensor, and it's the LSS05, not sure the actual brand. But what we have here is 5 infrared emitting LEDs and 5 infrared sensing LEDs, and they pretty much pretty accurate. I have a line pretty much set up here so that we can show you on this video what this little unit's capable of, and really quick setup. Onto the big bucks. This is the Devintech MD25. This is the motor driver and controller, and what it is pretty much you can control a 2.8 amp circuit, up to 2.8 amps per circuit, so it's 2 motors that you can see connect here and here, and also Notice that the motors are 6-wire with the 4-wire encoder, and the 6 pins in, so they go pretty much 1-to-1 with the motors, and that gives this computer opportunity to control not only speed, but also it can control turn commands, so we can do differential wheel speed for our turn commands. So this board's really going to help us save time on programming and stuff, and hopefully we can harness the technology pretty quickly and understand what's going on here as soon as possible. So on to the next set of sensors. We have these three. They are Sharp 2Y0A21 infrared sensors. These apparently sense 10 to 80 centimeters in distance. And what we plan on having is 2 sensors on the front of the vehicle. Let's see if we can model them up here. So 2 sensors up on the front here of the vehicle, right next to where the A-arms are going to mount on. And those are going to be able to sense distance, but also if we're following another robot, they're also going to be able to tell it to correct a direction and which way it needs to turn in order to follow the robot. So I think having 2 sensors up front is crucial. Also for it being able to sense corner objects, or this vehicle is pretty wide, so I think 2 sensors up front is going to be definitely helpful for us. And then in the back of the car, we're going to have a single sensor. I'm not sure, probably mount it right up top here, right in the rear of the car. This is obviously for sensing objects in reverse, and also providing some sort of infrared signal for any following program for the next robot to be able to follow this robot. So that'll be interesting to see how we can utilize these infrared sensors. And as I promised, I was going to show you a picture or a quick little snippet of what's going on with this line tracer, because I got it to power up really quick and be able to sense a line. So I'm going to go ahead and plug the Arduino into my computer really quickly, and that should just power the unit. So as you can see here, we have the line tracer. I've already set up a couple of lines, one being a thick black line and one being a thin white line between 2 black surfaces. So let's go ahead and see if we can calibrate this unit. So we're going to push the calibrate button on the side here, and it's going to give us some flashing LEDs. And we're going to go ahead and just put the right over the line, and there it is. It's pretty accurate, and it can sense from about 4 centimeters, which I haven't been able to achieve yet. It's pretty much about 1.5 centimeters where I'm finding it's having the most accuracy with the line. And you can see here. It's pretty cool. And let's see what it does with the black and white line here. Pretty much finds that white center there. So we'll have to perfect it and see how we can utilize these signals to control our steering mechanism to follow a line, and I think it should be pretty fun. So follow along with us and hopefully see what we're coming up with, and pretty soon our chassis parts are going to be in. They're leaving Hong Kong pretty soon, so we'll have a working suspension pretty soon, but as of right now we're going to work on some programming, see if we can get everything working together, because as far as I see it, once we get the programming all done, it's a matter of bolting it all together and we should have a working robot. So I think most important is getting all the hardware and software all together, and then pretty soon we'll have some pivoting parts and suspension components and some wheels, and we'll see this vehicle come together. And with your guys' help, I really appreciate it. This is so much fun. So until next time, thanks again.